everybody. So my name is Linda Mazzitelli. I am no longer the ECAD Segment Solutions Director at PTC. I joined Altium about a week ago.
Yeah. Thank you very much. Yeah, you're going to need...
But my role at PTC was from an enterprise
Take a
data
picture.
management perspective, and that included ECAD-MCAD collaboration, along with what would be, the Vault tools here, the Nexus tools, Concord Pro, and
Yeah.
such.
Yeah.
So I've
Thank
been
you.
talking
Thank you.
about this for a long time. Glad to see you all here. I know it's the last day and the last session of the day, so I do appreciate you being here. So what we're going to talk about today is ECAD-MCAD collaboration and CoDesign. So before we get started, I just kind of want to get a feel for, are there any MCAD people in the audience? Hey, we got one.
Yeah.
All right. That was better than I did in January.
Thank you for joining us.
Both.
Okay.
So that I'm actually starting to see a little bit of a trend where people are doing both, just like engineers are doing boards. I'm starting to see now more mechanical people getting involved in board layout as well. How many people use, just to get a feel from an MCAD perspective, PTC tools, Creo? Anybody using SolidWorks? The majority. Anybody using anything else? Inventor. Okay. Great. Cool. So, so we're just going to go through a few things and talk about the challenges, the use cases, considerations, the flow of data, as well as the benefits of moving to hopefully a more integrated solution. David and I are going to then do a live demo for you and show you how the collaboration could work in a more unified environment. And then we'll summarize the day and you can go forward. So today, how are you collaborating? Are you using file-based transfers, mostly STEP? Who's using STEP mostly? Okay. Is anybody
Quite
using
a few.
what was it? Oh, anybody using IDF or DXF? Okay, so mostly STEP, DXF as well. With STEP? With STEP. So to bring over things that are, sure. Okay. So from an industry challenges perspective, and I had the opportunity to sit in on a number of the presentations this week, which I thought were awesome. But this message really kind of was coming through loud and clear, right? So my background is board design. So, I would say gone are the days of those big motherboards for the most part, where you could just, slap a whole bunch of stuff on there and make the board bigger if you needed to. Now, everything is driven by enclosures, right? And generally that's driven from MCAD to ECAD in a way that enables you to ensure you have the right dimensions before you start your design. Connectors and mounting holes, so making sure that there's alignment from both the MCAD side and the ECAD side has always been challenging. Mostly we've got a grip on it today, but I still have customers telling me today that they will assemble a board and the connector is 180 degrees out from what it was built from one side or the other. So that occurs occasionally. Making sure that the rotation, orientation, and mounting holes are correct across all connectors, and any parts that have those same criteria is very, very important, because otherwise, I don't know if you've ever experienced this when you do a collaboration, but you could get a part that's perpendicular through the board, and that's probably not how you want to build that. Being able to see assembly, screw shorting, and the electrical connection on the PCB as well, and on the mechanical, right? So just kind of do a visual check or even an electrical check on the MCAD side to ensure that even though there's keep-outs, you define and design your boards with keep-outs around your holes, still giving it that last check just to make sure there's no shorts when you torque that screw head down, right? And then ultimately, looking at your enclosures and being able to ensure that there's no collisions, whether the boards, components, or daughter cards, or anything else that's associated with that project as a whole. Right? Does this kind of cover, is there anything that you see that I haven't talked about? No? Okay. Okay. That's a good point, though, the harness design as well, and taking that into account. Yes.
Yeah.
Very good point. Thank you for that. Okay, so communication challenges. So while STEP is a good format and file-based transfers are of course, the most used formats today, because it's pretty much all we have, still the challenges arise because it's still an over-the-wall, right? Even though STEP is an efficient way of communicating, it's still over the wall. And being able to communicate still requires README files in some cases, emails, markups, I've changed this in this area, so just look here. So the communication isn't quite all, all that it should be, right? Hopefully we can, look at a way to make that a little bit easier and make sure that it's more accurate. So the problems that we see, again, is that just being able to connect and make sure we're communicating the right level of information to the right people is still a little bit disjointed. So how many times do you all collaborate on a regular basis? So is it like once at the beginning and once at the end, or do you collaborate like multiple times throughout the process? What do you typically see? Through the whole process, so multiple times. Okay. So,
How many times would you say, like back and forth?
Probably at least 10.
10?
In our current project, probably
Twice a week?
It's been going on a month.
Wow.
It's just been that way.
And how long does that take each time?
In our case, it's pretty good because my MCAD guy is just diagonally across.
So you're just like, hey.
Yeah, that or toss something overboard.
Like, but physically.
Yes.
physically, right.
So, open floor plans are good for that.
Every time we do a prototype, we win the wall. 3 or 4 prototypes each time, it comes up a little correct.
Yeah.
Oh, did I mention I moved that?
Yeah, exactly.
Release my data into our PLM system so that then the MCAD tool
Yes.
that they're using for Creo can pull all the data down.
Yep.
And then they say, well, that's kind of interfering here and there and here and there.
Okay.
Painful.
Yeah.
Especially because they can't give it right back to me in a native format like some of the new stuff is hopefully going to do.
Yeah.
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 We all want to, we want to say, we don't know how much circuit or device we're going to use, we design it, they say, well, we don't know how big to make the box.
Circular reference.
Yeah,
You're like,
yeah.
well,
It's going to be 2 inches by 3 inches.
Yeah, exactly.
That means an origami PCB.
Which there are some of those now. But everything you're saying is exactly the reason we need a more efficient process, right? Because right now, anytime there's a file-based transfer involved, you start looking at, did you read the right one in? Did you read the right one in the right order, right? So how do you know that you're actually doing what you need to do? So that, as you all just said, it takes time, right? Because each time you have data transfer, you're waiting for the other person to ensure they got the data. And then how do you know whether they accepted that data, right? So you send your file, you send your step file from ECAD to mechanical, let's say, and now what? You're waiting. Do they ever get back to you, or do you have to prompt them? Was that okay, right? So it takes time.
It gets their attention when you go in and sit on their desk.
That would probably do it. So also accuracy, right? Again, just making sure that you're reading in the right files at the right time in the right order. And that leads to some form of lack of control. Anytime you have to manually control the way things are read in, when they're read in, how they're read in, that leads to a lack of control, which leads potentially to errors, right? So from a typical use case perspective, and I'll ask you guys, but what I've seen is that 90% is probably, and let me qualify this, new designs, starting from MCAD and going to ECAD. Is that pretty much how you guys do it, or again, new designs? All right. What David and I are going to demonstrate to you is actually the scenario will be an existing design, which in many cases now starts from ECAD and then goes over to MCAD, right? So that's what we'll be demonstrating to you. But this is the typical use case that, and working for a company that was primarily MCAD driven, This was the use case that I typically saw. So in terms of goals from a business perspective, so I think Lawrence said it, for those of you that were in the keynote, or actually it was the keynote speaker. What's his name? Sorry. Robert. So he said that the issues that people are seeing is that not only, so what you think is going to be an extra step for you, right, really will benefit the overall enterprise as a whole, right? So that's important to understand, because not all the things that you see from a collaboration perspective, whether it's ECAD-MCAD collaboration through a cloud, or whether it's ECAD data management, all of that may not, you may not see that as a direct benefit to you. However, from an enterprise perspective, it is going to be a huge benefit. So a lot of the companies now are looking at 80% of products launched on time, right? That they are decreased in development time, that the products meet the targeted cost goals. Now, think about cost goals, not just in terms of a first release, but in terms of field readiness and being able to maintain those items in the field, right? So if you have to recall items, you're an auto manufacturer or anybody else with high volume, costly products, well then you better make sure that your products are, very reliable in the field. 11% decrease in product cost goes right to the, the top of the bottom line of a company, and making sure again that the quality targets are maintained and improved upon. Okay, so in terms of transfer now, what we're going to be talking about further and showing you is the ability to actually basically just do a push-pull of your ECAD and MCAD CoDesign data transfer. No more file management, no more worrying about which file you read in or when or who sent it to you. It will all be managed for you via the Altium 365 or Concord Pro or Nexus or whatever you may have in that realm. But this is going to ensure a very easy, reliable process. It'll include traceability. And the other nice thing is, remember we talked about being able to, or today the process being where you might send README files, marked up PDFs or whatever. All that will be included. You'll be able to communicate electronically with your counterpart on the other end of the design process. The other nice thing is, how about when you send step files now? How does somebody say, I don't like what you did, you need to put it back, or you need to do it this way? Again, it's time consuming and it requires documentation that usually gets lost, right, at the end of the cycle. You have the ability to accept or reject changes electronically, have that history retained, and then have the ability to actually include that with your release design.
Is the multi-project going to be able to go back and forth?
Yeah, that is like a roadmap item.
Oh, it is roadmap.
It's not currently, there is stuff you can do, and you'll see a little bit how you can kind of work with it on the mechanical side if you know what you're doing. But it's not the full multi-board project right now. That's something that we want to be able to support in the future. Obviously, we're still developing the whole multi-board capability on our side, so we want to get that more established and used before, you had a question in the back as well? I forgot I'm supposed to be handing these out. Yes, sir.
Oh, solid, yeah. I don't know that it wasn't available. All I know is it is available now.
So that's more of just how communication breaks down when there's all of this, companies working together. It has been available and has been supported throughout all of this. When there was the release of Nexus server, there was a lot of communication breakdown that happened in general. And that was, no, it was just communication breakdown. Still available. And right, in Nexus, in Concord Pro on premises, and now on Concord Pro available through the 365 platform. So, sorry? You need a managed repository, server. So you would need that, right? Exactly, but you needed a PCB services, which was a lightweight, just component system that didn't, it was just really stripped down. No, that still exists. It's just stripped down version that doesn't have a lot of things, right? It's the PCB services, I don't know exactly the name. You said you work at SolidWorks, so you should know what it's called, but we don't sell that product, so I don't know. As I was saying, Linda was actually talking, so I wasn't saying anything.
There was a question over here.
Walk me through the connectivity. Another part of it, I'll check my design to Concord. We pull it from Concord. Machine, server, machine.
We'll go into more detail.
This new system, you don't have to go through Concord to connect the two together, right?
We'll go into more detail.
Yes, you'll see that in the demo, but the short answer is yes. As David was saying, it has to be a managed system, right? So it's you need a
Yes.
Yeah.
Yes. And I'll explain why and all of that, but it's in there, and I'll explain. Let's just get there. Just wait a second. Any other questions? Let's keep going then.
Okay. So essentially, this is the UI, right? So this is Creo, yes. And there is a plugin called CoDesigner that goes right into SolidWorks or Creo or Inventor. I think you guys have Inventor. And it is basically, as I said, as simple as a push-pull, right? So if you're accessing data from Altium that was put into the server, you can pull that down. It gives you a list of the objects that have been proposed or changed. You can, by accepting, rejecting that I talked about before, you just unclick things that you reject. You then get a dialog box. You can say rejected because, blah, 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 or why did you move that, right? And then you can simply push your responses back to Altium. So it's very, very simple. And as I said here, you see the activity. It keeps track of all of the updates that have been made throughout the course of this design. So if you ever want to go back and say, why was that connector moved? I don't remember anybody, moving that. You can go back and actually look at the history and see, whether things were moved. So it's a very, very easy process, and it tracks everything for you. Okay, so what happens then is you're literally taking the time out of a manual process, time and error. You're much more accurate in your collaboration back and forth. And you have full control over the data. So that data is controlled in a managed environment. So no longer is it a manual process to take care of files that you need to transfer back and forth and potentially, again, read things in an incorrect manner. So in the end, you've got a whole series of communication now, not just between ECAD and MCAD, right? So branching this off so that you can tie design processes and the entire process to whatever PLM system you're using as well. So how many people are using PLM today? And what are you using? And Agile. Okay. So, you'll have that integration now. With your MCAD teams, you have the ability to connect up ultimately to your ECAD data and pull that all together. But that's a whole nother product that we will not talk about here.
Yeah.
So with that, I'm going to hand it over to David and let him take it from here.
Could you keep the, because I just have the mouse, so, yeah. Okay, so we're going to start off by just talking about Concord Pro initially. So Concord Pro, as we announced today, will be the first thing available on the Altium 365 platform. So, some of you might have been here yesterday with my talk with Ari Mapur. Altium Concord Pro is available on premises still, so for people who don't want to be on the cloud, right? There is the ability to install this on premises, completely removed. But now, as of today, you can also use it through Altium 365, and it will be completely hosted on the cloud. All of that will be available there. Yeah.
If you've got an existing vault installation and you bump up to Concord Pro,
Yes.
is the data that you've already got?
Yep. Yes. They're based on the same platform. The Vault, it's essentially like the next iteration of the Vault technology, right? So it's just the installer. We'll do that for you.
Okay.
Yeah. Yes.
But if we do have like an on-site server where we're currently hosting the Concord,
Yes.
to go to the cloud-based server, is that, I mean,
That's possible.
easy transfer process?
Yes. Yes. Yeah. The whole idea was to make that as simple as possible to get to that. And the whole aspect of Concord Pro, we started talking about it as component management. Why component management? Because it's stepping away from the whole concept of the library, right? It's no longer individually managing the schematic library, the PCB library, all those individual aspects. It's the holistic management of that component entity, the unified component model, right? It gives you all of that information, and it helps you fully leverage the project management capabilities that are also available here. So you can use an SVN repository or a Git repository to do your project management, and you could do, you could see where all of these components are being utilized, update these components, do all of that. And because you have all of that rich parametric information, all of this model information, you can easily pass this back and forth. As you were stating earlier, why do you need to be on the same server? Because all the information is stored on this server, now we can translate this information into the Parasolid format, and it will be read in natively into these tools, right? So now you have a native assembly in the supported tools, which I will go over in this next slide, right? So you have SolidWorks, you have PTC Creo, and Autodesk Inventor. As the gentleman in the back mentioned earlier, with SolidWorks, you do need the PCB connector license. They have requested that you must purchase this license. With Creo and Inventor, you do not need to purchase a license. You just install the plugin, and you're good to go.
I don't have I mean, I have Creo license already,
Yeah,
and that's all I need.
that's it. That's it.
Just to be clear for the couple of Creo people in here, PTC has a product called ECAD-MCAD Collaboration Extension. And just be careful there, because if you use this, you do not need that. But the PTC team may not really be aware of that, so just understand that if you talk to them about it, they may try and tell you that. But for this specific integration, you do not need it. It's just a plug-in.
Okay. Yeah.
It plugs right into the Creo interface, which you'll see.
Yeah.
But when you say, when I say sensor, what is that actually?
Okay, so when you install Concord Pro, or you wouldn't install Nexus, since Nexus is a solution, they will deploy it for you, but you would have this server installed at a certain location or host, right? Okay, so you access that server by the URL, right? The server address, and you just connect to it. So that's it. That's all I mean.
And Creo may have the same.
Yeah, same way. And we'll show you because we'll have to connect.
But the Creo database doesn't need to be on the same screen.
No. It just needs to connect to pull the information to have that. And then you can save it wherever you want. And you'll have the native files, right? And it'll be that native assembly.
They can go through the same version control checking.
However you want, yes. Yeah. It seemed like you wanted to say something?
Well, this ECAD, what are we talking about? I think we already have that because we talked to PLM already. I'm assuming it's some kind of a utility like that.
You very well may have it. They kind of throw it in
Yeah.
sometimes.
Well, we could talk about that a little bit later, yeah. So as one of the things that's really important, you have some level of configuration. Here you have the ability to fully export the copper details. By default, I recommend having that off due to the fact that you don't really need that information for all the time, right? It slows it down a little bit, so you can configure that on and off. If you have it off, we'll show the differences. It comes in as a decal, which gives you just like the overall picture of how the copper will look like. And you'll see a little bit more about what that truly means. And it just kind of makes you understand it a little bit. So you had a question in front first and then behind you. Yeah.
So I'm curious, how do you export that information? The other one that I found to be able to do that, it doesn't really work well, is I tried to do that with steps, and it doesn't let me do that. You only can do it if you have, I think, an IGES or something.
Yes.
And I guess my question is there a way to do it with step files? And if not, why not? Because when I export PDF or some information, it doesn't slow down. It puts everything in green layers, stack up, and copper.
Yeah.
So why would it be not possible for step?
I would assume it's something from the Parasolid, but I would have to defer to one of the, would you be able to give something? That magic. So Nikolai's gonna give us a little secret insight right now.
Introduce myself first, briefly. I'm a product manager for mechatronic design area, and I'm responsible for requirements, priorities, and overall vision in this area, this specific area. Back to the question about model components. As you probably know, in Altium or on ECAD side, we do support several ECAD formats for models. Maybe SolidWorks format, Parasolid format, and STEP. When we do raster design from ECAD-MCAD, we raster everything in Parasolid format. So we have an internal converting mechanism which allows to make that transformation, and especially building of the model on MCAD side much faster, and which allows us to be, I would say, universal relatively to all the MCAD support. So it is not that we exceed support of Parasolid format, and when we are building model on MCAD side, we are building native MCAD models anyway, using those Parasolid models which we send to MCAD. I hope I answered. If not, tracks.
You want copper, Nikolai.
Yes, back to the question, yes, about the copper. So we actually built it. We send the information as contours and thickness, and we built copper as an extruded feature on MCAD side, and it is available with special technique of which allows you to items inside design on the side. And for example, rather than layout of the design, you have to precise placement of each, for example, of compartment and so on. And the second purpose, it allows you to do Catalan analysis, which is also important in some cases. So it's important to have that proper
So Nikolai, I believe his question was, why can't STEP include copper as well?
Yes, but it works within our ECAD-MCAD collaboration for now. And we do not do that with that. But for now, to be honest with you, I don't remember what was the reason for that, for not including that to separate one. But
When I export the PDF 3D is 1,000 times more detailed than where I export it to assembly. So sometimes I just wish I had a way to say, because you already do it. And it's not that big. It's, comparatively. So I guess my question is, why can't we do that?
You see, this is part of all of this.
When you practice how quick you can spin even complex things in 3D, inside of PDF,
Yeah,
I go like, wow, this is pretty incredible.
yeah,
my question is basically also this one too, but the silk screen layer.
uh-huh,
That comes in, doesn't it?
yeah.
Silkscreen and
Yeah.
solder mask come in
So-
during
so-
the basic
yeah.
collaboration.
So that comes in on here.
Yeah.
So,
Yeah. Yeah,
yeah.
yeah.
Well, it's something, yeah, well, we could talk about it a little bit more after, because, that's, those are good points. Yeah.
If you do with parasol, you can go bi-directional,
Right.
Yeah,
back into Altium.
Yep.
yeah,
Yep.
Go Altium to solve and solve
Yeah.
back into Altium.
yeah. And I think, one of the most important things about this conference is being able to have this communication. Like after this presentation, we're going to open it up to an open discussion. I think we'll probably have like 20 or 30 minutes. So start thinking of like some things to stump us. I see that smirk. I see it. He's like, oh, I got some right now. Okay, let's keep going. So as far as the capabilities for the collaboration, it really enables you to fully cooperate with all of the 3D models. As I mentioned earlier, you have all of that parametric information as well. When it's bringing in the silk screen, you could actually see the different reference designators on the board. You're able to see things such as the logos that you could see on these images right here. And you can enable things, as we just talked about for a little bit, the copper details. And I think it's really important to have this level of traceability with the annotations. And it's also nice that you can see who made those changes. When it's just two guys and you can just yell over the wall, it's one thing. But when you start having, more than a couple of people, it's really important to be able to say, this person made this change at this time. They made it at midnight. Maybe that wasn't the greatest design change, and you actually have the capability of rejecting a change, right? Like, maybe it's not the best change. Sometimes, we make mistakes, and we have to hold each other accountable for that, right? So that's important. So as we talked about earlier with that, the fact that it's native files is really important as well, because it allows everyone to work in an environment that they're really comfortable with, right? You're not trying to get this mechanical person to understand this whole new tool and vice versa, right? It's great when you do a little bit of both, but if not, you're not learning something completely different, which is really great. You can do a lot of things with the board shape configuration. You're going to see a lot of that in our demo right now. And my favorite thing is how easily it is to optimize the placement of edge connectors, right? We're not going to do too much of that today, but it's just really nice that you can do that. If you're really familiar with the mechanical side, you know, it's really easy to do on the mechanical side. And when you have the enclosure as well, it's something that's really great. And I think in the future, scaling it on a multi-board level, I think that will be very useful as well. So,
Oh, go ahead.
yeah.
That get basically folded up into a stack.
Yeah.
And there are connectors down, say, on the middle board, poking up through an open, and others that are two connectors that they're mating up here, and trying to align all of that.
Wow.
And we did that by hand only because it was just, usually what I would do is take a DXF, outline or something, flip it over, import it, and use that to align.
Did you try the multi-board stuff in Altium Design?
I'm not sure how long ago I did this
Okay.
particular outline, so I'm not sure if multi-board was up to it at that point.
Okay. Because we do have the mating capabilities in the multi-board stuff. I'm sorry. I didn't catch any of that, but. Yeah. Yeah, you could bring in the fully folded boards into a multi-board design now. So that's really nice. That was introduced in 19, so you can have kind of what you're saying, that full thing in there. So.
Yeah, it would have helped with the time. I think we were using 18.
Yeah. Yeah. I that's something. That's the flex support on all of this MCAD stuff is something that's definitely on the forefront of our roadmap, as well as some other things we'll talk about after we do some demo. At this point, I found out yesterday I have to close this out for some reason.
Just another word about traceability that David was talking about, seeing who did what, when, and why, right? How many times as board designers are you told, this is it, the engineers, this is the last change they're going to do, you do your design, and we are locked, right? And then the engineer comes over and goes, could you just move this one little thing over here? Can you just add this one component or delete this, right? That happens all the time. So one of my customers, when I was at PTC, took these traceability files, and they went armed into design reviews because ECAD is the last people to touch it before it goes out the door, and they're always the one blamed for the design, the project being late, right? So they went in with these files, and they said, look at how many changes were made, by who, look how long it took us to make them, and they didn't do it to point fingers at all. What they wanted to do is triage it. They wanted to see, are we making the same mistakes on every design? Why are we having so many iterations after the design is locked? So they actually used it to improve their process, right? But it was very, very useful for them to really understand what was happening in a bigger picture.
Well, you know that this is the last change promise, right up there with your check it in the mail.
That's right. Exactly.
Okay. So from here, I have a little example project.
I have to bring up Creo, isn't it?
Yeah.
Is it open? Yeah, there. Sorry, we're just getting everything set up so we don't have to do it during the demo.
Okay. Here.
And the other one next to it.
I'll just look
No,
a little bit faster. So what we're going to do is, this is the second iteration of this design. We've created a brand new enclosure here. What we're going to do is bring in the board from Altium Designer into Creo and change the board shape a little bit to get it to fit the enclosure a little bit better, right?
sorry, I had to close that.
So we're setting up the environment a little bit.
2 seconds. Where are you in? Here?
And does this now
In here?
work in 19? Or is this going to be a?
Yeah, 19. Yeah, this is 19 right now. Okay. So we start off with the design. And the first thing you want to do is there is a panel, right? So we have the panels here. Once you have your PCB document open, you open up the MCAD CoDesigner. And I want to push this design. So I am going to put a comment as the ECAD baseline. So I'm going to post this. You see here, it's putting up all that information onto my server. And as I mentioned earlier, this is actually Concord Pro on Altium 365. Right? So this has now been uploaded to that cloud server. I never switched to the fast internet, so whatever. We're just using the free guest Wi-Fi.
Let's see what happens.
So let's switch over to you.
Okay.
And now we are in the Creo environment, and this is the new enclosure that we've made, right? So now Linda can use the CoDesigner panel from her side, right?
Right. So this was a plugin on the Creo side. It said CoDesigner. And I invoked that first to bring up the panel, and then I opened an existing enclosure. Right? So this is going to be a unique situation, again, where the use case is it's a design that changes are being made on. So it's coming over to MCAD, and it's going to be really unique because we're going to give David more room on the board, not less. So, so I'm going to pull the board. Exactly. So
Future.
So, which one is it, David? Is it this?
Poly.
Just Poly? Or to Poly and Linda?
Poly, yeah. Actually, we should check just to make sure.
Yeah. Yeah.
Should be Poly. Yeah,
Poly.
projects. Yeah.
Okay. So what we just did is we just double checked to make sure I'm going to pull from the right project, right? So let's see, we're going to save this now. And here, and you want it just in there. Right?
So, and as we said, now you can save this wherever you want. So we're just going to save it into a folder on my documents, so it's nice and local. So you have a working copy. And it's going to create those native files for you.
Right, and this is where we see if our internet connection is going to cooperate with us. Oh, looks like it probably will. So it's going out, it's just looking at the server, and it's looking for that, saving that design that I just created, and there it is. So it pulled in the data from Altium and created our, absolutely. Absolutely. So, yeah,
Well,
word about
so these
that.
these are decals, right?
Yes.
And we're gonna give more information on this
Yeah.
right now.
We're going to
But-
show you what happens with this. So the decals, or just think of them as basically lightweight representations of the etch, right, in the copper.
And of the polygons and everything.
Yeah.
Right.
Yeah. So now I'm going to go over to the enclosure, and I'm going to assemble that board into, whoops, wrong thing, too fast. We're on a slippery slope with this mouse, so it like.
Yeah, we're like, we need a podium. They're like, okay, we'll just give you this like gigantic slant on this podium. That's good.
So, and we're going to just pull in this a poly here. And you'll see that we have the board. Now, I could do coincident areas in here to get this associated to the enclosure, but I'm going to cheat, and I'm just going to use the drag handles and pull this over. I'm going to tilt this a little bit so I have a little better view of what I'm doing, and then I'm going to pull it down. All right, you of course would do it a little bit more accurately than this, but in the MCAD world. But I think that looks okay. Yes, it does. All right, so that looks good to me. I'm going to just say okay. So now we've got the board in the enclosure, and I say, wow, look at that. Look at all that room up there. I'm going to give David a lot more room on this board. So I am simply going to select the board, and then over here I am going to expand the feature list here, choose the board outline, and say Edit Definition. And I'm just going to drag up. Of course, you can do this by dimension, right, for the mechanical guy in the room that's freaking out right now. So I'm just going to do this freehand, and then I'm going to add a couple of fillets. Okay, just to make it.
But you're operating with native Creo commands right now, right?
I am,
Yes.
yes, I am in Creo right now. Exactly, exactly. Okay, and then I'm going to say, okay, so now we've got an expanded area. Look at the decal, all right? As I said, this isn't real copper. This is just a representation. This will get updated in the next couple steps, so don't worry about that. I'm just going to pop this to the front real quick, and I also am going to make a change to this component. So I'm going to drag this component. Again, you can do it by dimension, right? So right now I'm just going to kind of pull it up here, freehand. All right, and then I'll say okay. All right, now I want to communicate these changes back to David. So I'm going to go back to my panel. Now, if I bring up this panel here, you're going to see the current assembly is not linked to a PCB design. Oh, no. It's okay. All you need to do is go back to the board, because that is where the actual collaboration is done at the board level, at the board assembly level. And you'll see here that the board outline gets updated. Show that to you here. And the resistor is moved, so I'm going to communicate that back to David. So we'll use the panel, and I'm going to push my information. I'm going to say modified, if I can type. I can never type when people are watching. Board outline, and then I'm going to say moved R3. Okay, I don't know if I spelled that right. And then I'm going to post. Okay, and now it's pushing that data back up into the server, to the cloud.
To the cloud.
Beautiful cloud. And
Okay.
David is going to pull that down.
So then I come back over here, and I'm able to do a pull. So from that pull, this is one of my favorite aspects, is when I click on it, I can actually see what has been changed, right? It gives me a little overview of that, right? So I can decide, do I want to make that change or not? Right, I can kind of visualize it and see, okay, I don't like that component movement, that's kind of strange, so I'm gonna just do the board outline. This is a synchronization of the components between both sides, so I'm just gonna apply those two changes, and I don't want to apply the change for that component.
So he's rejecting R3, right? He's rejecting my move of R3.
So from there, I'm.
How do you like being
Yeah. So
It happens every day, multiple times a day when I'm dealing with this.
rejected R3 change. So now I'm going to push that over. You know what? It's too late. I was going to cancel it. On top of that, I wanted to come back here. Well, let's,
Yeah, let's just go through it. It's okay.
Right.
So what David was going to do is update one of the poly shapes and, bring it closer to the board outline, just to show you that anything that you do here will also be communicated over there. But
so as we, here, let's see, Polygon Actions. I'm going to modify this border here.
I mean, you're using board clerks rules, you don't have to do that, right?
Yeah, but this board,
It's a Polygon board, right?
this board, this was manually defined, so I kind of had to. But yes, if you are doing it not like it was done in this design, which I did not make, then yes. But since it wasn't made like that, I had to modify that shape. Right, so just to give that stark contrast, I'm just going to modify that single polygon pore and say change polygon pore. And then it's going to take a little bit. I'm going to wait for it to register and switching back over.
Yeah, okay. So now I'm going to go ahead and pull from the server. And what you see here is a couple of things. So first of all, remember we talked about the decals. So, and I said that those would update. Here's where that updates, right? So there's all the changes it detected on the Altium side, and it's all those decal changes. Also R3, it says placement changed. Well, I changed it, right? But it knows enough that when David sent it back, it's different from what I have here, right? So I am going to go ahead and say, that's fine. We can keep battling back and forth, by the way, and I can reject his rejection. I'll show you to reject me.
So currently on the SolidWorks side of things, you could see that movement that you saw on the Altium Designer side. That movement is also shown in SolidWorks. That is being developed for Creo as well, I believe Inventor too, right, Nikolai? The movement thing? Yeah, so that's being developed for Inventor and Creo as well, but currently you can't preview the movements. What? Inventor.
Inventor.
Autodesk Inventor.
Autodesk Inventor.
Yeah. You're like, what? Why? You're like, you can say that? So as you can see, the polygon pore is, there's that stark contrast there, so it's really easy to see. So there you go from that's the middle of the road. I now wanted to show one more thing.
I have one thought on this, just to finish off.
Eventually, we're going to be able to have traces here.
You have the ability to bring in traces. So right here, under the gear port here, if you tell it what to model copper collaboration, it will bring in the traces. So if you check that box, it will bring them in. The only reason we didn't is because it takes a long time. Yeah.
You want
yeah.
Let's go on the wild side, Linda. Do it. Join the dark side. Do it.
You want me to do? We have time.
Do it.
Okay. I will actually. Yeah. Let me go ahead and do that now, and then I'll explain a couple of things here. Let's see. Model copper. Do I need to fill in anything here?
This is we like to be risky. But yeah, things have been going too well, so we're just gonna.
Yeah. Really. All right. So I selected it.
What's the opposite of a Hail Mary?
What do we need to do to actually get it, bring it
Yeah,
in?
and then just pull again.
Oh, do it, Paul, again, okay. Okay.
Yeah.
So the one thing I did while this is going, notice the decals, right? Remember the decals were offset? Well, now they're back. As I said, we saw them come in. The other thing is that the resistor that I moved up here is now snapped back to its original location because it was rejected. So all of this is tracked for you. The history is there. You can always go back to see who made what changes, why, and when. So it's pretty powerful in terms of just being able to manage your overall process without having to worry about file management and transfers and what file to read in when and who made what change. If MCAD's working on a change and ECAD's working on a change, that is managed for you through this process as well. Through file data transfer, it's not. Think about it even with STEP, right? If ECAD's working on a change and MCAD is, how do you rectify it? And what if you're working on the same thing for that change, right? You're both moving the connector in opposite directions. So, yeah. So typically, again, it does take a while for traces to come in. Our recommendation, it's totally up to you how many times you want to do this, but probably at the end, right? You want to bring everything in, check for clearance violations. You want to do any simulations like thermal or stress or whatever. You know, but again, you have the option to do it as frequently as you like.
Is the slowdown entirely limited to the import, or does it affect the model within Creo?
Not sure I understand your question.
Well, I'm saying, when you bring in the copper
Yes.
as a valid object, is the time penalty just on the import?
Oh.
Or does it significantly affect the?
It does, and this is not just true for Creo, it's true for all the MCAD systems. Yeah. It's so, and we can talk offline, but basically at PTC, we took a different approach for IDX, for import, only because it creates so much overhead on the mechanical assembly side, moving parts, anything like that. Just think about it. And if you have a large design with copper pores and all that, it's going to be even more difficult.
Does that make sense?
Is it, or does it still, even with the detail, does it still bring in an accurate overall board thickness?
When you come over from ECAD to MCAD, because MCAD doesn't understand the board thickness based on the layer stack. Right?
So when you get the board thickness from the initial, from the ECAD to the MCAD side, because let's say you were doing.
I just want to show reference designators, I'm sorry.
I have no idea.
Right.
It brings over the overall board thickness, the exact thickness, on the first time you go from ECAD to MCAD.
Right, so your overall thickness, he can still work with that in.
Correct, so if you have some screw losses, or if you're going to be placing your PCB where it might be kind of sunken in or offset somewhere, it will take in and measure the exact thickness that comes from the layer stack.
Yeah. And in fact, I'm glad you brought that up, because sometimes you think, I didn't make any changes to the board, and you see the board come over. It's for that reason, because the stack up on the ECAD side may have changed. And so now it's going to bring the board outline in. But that usually gets people. They're like, why is the board outline changing? And I didn't want it to change. It's not,
The board outline
yeah.
preview in that menu, and that's what she's saying. She's like, why is it there? We didn't change anything.
Yeah.
But when you look at it in the SolidWorks side, it shows you a description of what you're bringing in, and it says it there.
Yeah.
Yeah, my buddy would have killed for his last time. The stack up got changed partway in between, and he never noticed it.
Yeah.
And we just got a bunch of 039 boards that are.
Oh, yeah, that hurts. Can you just go back to Creo just for 1 second? I just want to show them the ref des.
Yeah.
So anytime you're doing that push and pull, whatever information is on the ECAD side, if you miss that push, it'll give you the right.
Yeah, that would have been.
It would have been. Now you know why this is
The operative word. So, yeah. So I'm asking David to just, when he's done here, pop back to Creo for 1 second. The only thing I want to point out to you, because this was always a common question, is what about my reference designators, right? So from a use case perspective, again, this was the scenario of a board that already existed, and we brought it into Creo. The ref deses come in when you do a pull from Altium. Okay, it recognizes those, it associates them to the correct parts, and it reads the Altium database and associates the reference designators. Now, one thing if you're going the opposite direction. So if you are coming from mechanical to Altium, and maybe you don't know, you want to place your connectors, but you don't know the reference designators. There's still communication that has to go on, right? You have to talk to your electronic engineer potentially and say, I have these part numbers, what are the reference designators? Or you can place the connectors, or whatever they are, on your design. You can shoot them over to Altium. Just say, place them anywhere, just so you get the reference designators, and then send it immediately back to your mechanical system, and you'll have the reference designators then, and you can place them in the appropriate spot. Okay, so those are just kind of a few little tricks.
Same thing with Altium. Start with Altium, place them.
Absolutely,
Yeah,
absolutely, absolutely.
And
CAD can adjust it.
Yes, correct.
And I do want to say that within the coming months, we are working on releasing initial placement from the mechanical side, and then you will be able to, you see this ECAD ref designator? Or I'm not sure, is that the parameter? You could basically synchronize it by the parameter name to your existing component you map it, basically. So if you have a more complex mechanical model, or you just want to get that initial connector placement, you'll be able to do that. I don't know all the exact details. If you want more information on that, we can talk after, because Nikolai can tell you about that.
Yeah.
But it's a secret, but you guys are all loyal. So even though this is recorded.
Did you have a question? Yeah. Yep. That's what, I'll tell you, that's what most people do. But there are multiple, there are multiple ways to do it. Did you have a question?
It seems to me, maybe I'm wrong, that what we've got here is we've got fundamentally a file transfer going from one place to the other, and we're using your Concord Pro as a revision control system that's handling the legwork of passing the message.
That's right.
back.
That's right.
But it seems to me that we could just pass that file across and reference the file without going through that network. If indeed, in the case of my engineering department, where MCAD is on this side of the brain and ECAD is on that side, and I really don't need the overhead of going to the cloud.
So let me give you some real, and I did this at PTC every day, right? And the biggest complaint that people had with file-based transfers is ECAD makes a change, and they send the file to MCAD. And then they're like, they keep working, and they make another change, and they send it to MCAD, and they make another change, and they send it to MCAD. And they're just stacking up these files, and they're naming them all kinds of crazy things. I changed this, I changed that, So what happens is, on the MCAD side, they all of a sudden get notification that there's changes, but not what order to read them in, how they're managed, how they should be just contained, and as a result, you had because the files are not cumulative, so they're not adding to the file. So there's not a single file that is being added to. They're individual files. So for file transfer, if you read something in the wrong order, you're potentially going to get a bad result. So that's why most customers, and when I was at PTC, we didn't have this. Most customers wanted this. Yeah. Sure.
Because it's my impression that when you hit that push button, it's that Altium is generating a XYZ file. And
Essentially, right,
along
David?
with that XYZ file is a bunch of text.
Mhm.
And that XYZ file is the entire design. The XYZ file goes across, when I do a pull on the other side, I'm pulling the XYZ file in, and I'm decoding it into Creo or whatever my MCAD system is. And when I do a push there, it pushes out an XYZ file and a bunch of ancillary metadata that goes along with it. And the metadata manager necessary for the actual transfer of the data back and forth. Are you saying that this, when I send out an XYZ file, I'm actually sending out 74 different XYZ files, one for each resistor and capacitor or something like that?
No.
Maybe they're getting loaded in a different order, which is
No.
what happens with the step files?
No, no,
I mean,
no. Think of it as an incremental file. Incremental from each iteration
So there's
that
XY
you,
So there's a pile of files that's going in, not one file.
yes, yes. So it's not, they're not cumulative. Is that, Nikolai,
Yeah.
that's correct, right? They're not cumulative, they don't append to each other. Yeah, yeah.
So we check when we send models, we do check if that model, that specific model is already on server.
Yeah.
If it's on the server, you're looking for differentials, but if it's no server involved, like you just send the file across every time in its full format.
So-
Because my
So-
ECAD, my Creo pulls all of the models directly from PLM.
Yep, yep, yep,
Yeah.
yep. So, but the issue with file-based transfer is, again, the file-based transfer is incremental. It's not one file that contains all the information together. They're not concatenated. You might have multiple incremental files.
So there's no history.
So there's history based on the individual files,
If I go
but they're
to the version
incremental
control
files.
system, version control system is keeping track of the change.
Yeah, even if you don't, even if you don't, they're incremental files.
It's all going across.
But-
Yes, the baseline is everything, yes.
so there's several aspects to it though, right? Because there's the design file aspect, but there's also the individual model aspect, right? Because you're first sending the overall board outline, and there are also the individual models for each component, right? So what Nikolai is saying is it first checks for each individual model for each component,
Right.
right? And then it pulls that model from the server.
So it's pulling a whole bunch of little XYZ files,
Yes,
just like my old step files with 1,000.
yes,
every lead
yes.
data.
But since it's a centralized system, right, Concord Pro, and it has your components data and your design data, it is using the version control system, combining it with the component management system, and doing that translation step all in one go. So it's doing several things simultaneously, right? So theoretically, you can do all of those things separately, but the whole point is that it's creating the user interface to create a user experience that isn't terrible.
Your user interface is wonderful, but I don't want to opt for Concord Pro.
So you can't, if you don't get Concord Pro, you don't have this bidirectional collaboration.
Yeah.
Yeah,
Through this interface,
Can't send it back.
through this
The
interface,
only thing you'll be able to do is export as a step as we currently
yeah.
do right now.
yeah,
Send that to your mechanical designer.
I
That's
do
a
that all
static,
day long.
that's a static.
Exactly.
File, that's a
Well-
static file exchange, right?
Right, but I thought this was a static file exchange.
No.
That was going back and
So this
No.
is why I didn't want to step in a little too early. There's no static file exchanges right now. Everything is being done through this server-based product. So there's nothing here that says step 1, rev 1, step 1, rev 2, step 1, rev 3. It's all one PCB project. That's all this, the Altium Concord Pro is acting as that communication bridge because the MCAD side and the ECAD side are both communicating to where ACP is installed. So there's no static file exchanges here. That's the benefit of it. What Linda had mentioned is that if you say, hey, Jamie, here's that, or here's that step, what happens if there's a change made and I forget to send you the wrong static file?
Right.
Yeah, exactly.
Right.
Sorry, for me, it's that.
But,
Put back and forth
right.
on my damn desk.
But let me.
it's that
yeah,
hemisphere.
But let me
It's the
also,
equator.
Happy to put it again or something like that, but while I'm getting this.
yeah,
You
but
won't get that.
let me also explain. So when I said incremental before, right, you saw when we did the exchange that only the things that were affected came back across. When step, you're sending the entire database each time, right? And then you have
The
to,
improvement here is that I'm sending parasolids back and forth, not that I'm sending steps. Because the parasolids are interpreted on both sides. Whereas step is only one direction.
No, but it is being translated.
Yeah.
It's not
Yeah,
that
it's
you're
not-
sending parasolids.
yeah.
It's being
It's
translated
being
into a native format.
Converted into
Right.
a native format, right. So, Val-
Yes. Yes.
The parent company buys all our seats,
Okay.
so we get a better deal.
Okay.
Right, so I've got an Altium seat.
Uh-huh.
We got floating seats. And if I want to have 365,
Yes.
let's say a contract mechanical person,
Mm-hmm.
do they have to have a seat on my company's Altium server?
No, so they can purchase with 365, it's slightly different. There's so with Concord Pro on premises, there are CAL licenses, and there's a very similar concept to that. So it's like a connector license because it's not necessary for the full Altium Designer. It's very similar concept. I don't know exactly because I focus on the technology. But remind me, send me an email.
Yeah, I'm interested because we also have people who live in other states.
No, that's an issue that is part of the technology. Like, you know, I don't know, right? Because there's no, I mean, with Concord Pro on premises, it'd be as simple as just I'd tell you, you would need a connector license, a CAL license, right? Like for example, right now, you can use a CAL license and it's basically an online web viewer, right? So you can see schematics on there, you can do comments, and you can see the full design, right? That also, I don't know, since I don't deal with the licensing, I have no idea.
I have a very, what I would consider more of a nuts and bolts question. From the MCAD side, I noticed that you guys are signed in. Are you signed in, like, say, with your MCAD license?
We're signed in with AltiumLive credentials
Okay, so on the
through 365.
on the Altium CoDesigner panel, you're signed in with your.
Yes.
So my MCAD person would need to have basically a sign-in from our Altium system. And they would sign
No, they would just they would create an AltiumLive credential. So you would invite them,
Yep.
and then they would make an account, AltiumLive account.
So they're not linking based on the URL necessarily, but they're linking based on their Altium Live URL.
Yeah.
Okay, thank you.
Yes, they would need a login. You know, it gives you a URL. You can define that, but the basic one, you can just put, well, wherever it's installed, you do localhost 9780 and you could go to it. But there's a basic URL that it tells you at the end of installation what that is. So you just type it in. And you could do that as well with the workspace, with like the 365 area. It's just a much longer URL because it's like workspace. And since it's connected to your AltiumLive account, you could just sign in directly from Altium Designer, so there's no real need. I heard a voice or something, someone. Okay.
So every demonstration covers resizing the board, components, and the MCAD designer also drill mounting holes in the board, directly place holes where they need to go.
As I believe that they create mounting holes? I know they can
Yeah.
move mounting holes. I don't.
Sure.
You want to make one? I know you can move them. I've never made one. I'm not a mechanical guy, right?
We do have a little bit of time. Anyways, for those of you, I've been chiming in from the corner, so please don't mind me.
Oh, I wanted to show one last thing.
Sure.
So Jamie's going to add to this, but I wanted to show, like, from scratch, you know, you could create a new board assembly. So this is test design. This is essentially, you're starting from scratch from the mechanical side. Most people would have an enclosure. They would create a board, right? You would save it, and you get a board in your environment. There's a fly. And it just creates it. Right, so I'm going to insert a component, which is my test design. Float. And I'm going to mate the board. And so I have this whole board here. Oh no.
Undo.
As you can see, I am not a mechanical designer.
I just want to point at that surface and say, give me a board that. That's surface.
Yeah, that'd be nice. That'd be nice. That's on, that's all, MCAD driven. So talk.
I can do that part if you want.
I must do it. SolidWorks has challenged me to a duel.
AltiumLive 2020.
Yeah,
Can we get that shading in Silkscreen?
Sorry?
Can we get that shading in Softmax?
You mean the actual
This.
board itself?
Oh,
Yeah, how good's your board now?
True. Okay, maybe Jamie has to help me. I'm so close.
he surrendered.
Wait, sketch. I'm gonna edit the sketch.
Just keep moving closer.
Okay, offset entities. Oh, it's happening.
1.5.
Oh no. Damn you, scientific notation. Okay. Right? No, I wanted that. Ta-da! Board. Right? That's my board now.
You're now a mechanical.
Since I mated it terribly, it's in the board, but it's a good shape. There is not a good thickness, but once I bring it into Altium Designer and it brings in my layer stack, it will have the thickness, right? And I was going to show all that, but I took too long because I wasn't good at the mechanical, so I'm just going to let Jamie make this hole now.
Yeah, no worries. So we actually had a presentation on the first day. Was anybody here for University Day? Most people were here for University. There's a couple familiar faces that you see. I had a full session actually demoing this as well on the first day with SolidWorks as well. So to come back, essentially to answer your question right now, yes, mounting holes are absolutely capable. The way that works is they can be done from the mechanical side and they can be done from Altium Designer as well. What happens is you can create a cutout in the ECAD side and it brings that over as a cutout. Whenever you create a mounting hole within the mechanical realm, it comes in as a cutout as well. So I'll be able to show that very quickly as well. We do have roughly about 20 minutes, so I'll make it fairly quick. What I'm personally going to do is, am I okay to make some modifications to this?
Yeah, just destroy it.
Yeah, have fun.
At least I'll copy it.
Just don't save it.
Perfect. So let's assume assume that we've just kind of wiped all the components off the board or whatever the case may be. And I'll go ahead and I'll push this over to a little bit different than, perfect. So here, we'll go over, we got one pull, we'll cancel that, and we'll push, and we'll just say we remove.
You should see the mouse fall.
I know.
Can everybody hear me okay back there? I have absolutely no problem yelling at people, so that's also a good thing as well. We're gonna have to decide. We will, that's okay, I'll start with you. I'm just going to. Just a little bit better? Good. Now I can really yell at people. Perfect, thanks. Yep, perfect. No, should be good. So actually what I'll do instead is actually, because you guys showed it starting from the ECAD side, a lot of times too, when I personally like to start it from the MCAD side, because from the Altium designer perspective, I don't necessarily want to do the layout and then have to redo the layout, because maybe I didn't have the proper board shape right off the hop. Maybe I already did some routing. I'll be like, cool, send this over to the mechanical person, and next thing you know, they're like, yeah, none of that's gonna fit, right? So it's a little bit, it makes a little bit more sense from the workflow side of things, that starting from the mechanical side, they can give you your accurate board shape right away.
Right, and I think we mentioned that for new designs, that's usually typical, right?
Yeah.
But for existing designs, sometimes you have to go the other way.
Yeah, the board might already
Yes,
exist within the
right.
ECAD realm, which is totally fine. So I'm actually happy you guys showed it that way, because that is the case in some times. So instead of pulling the board from assembly, we can also create a brand new project from the mechanical side. If it is a new project, the Altium person doesn't necessarily have to wait. The only thing that I would take into consideration here is if you're using a project template in Altium, this isn't going to create a PCB project with your schematics and your documents, right? So that's something to consider as well. If you're using a project template, just create your project within Altium and then tell your mechanical designer to throw you over a board outline. So we'll call it something along the lines of MCAD 1, 2, 3. And what this is going to do is it's going to create a mechanical assembly for us of that actual PCB. I'll just save it there. And it's going to bring in our default 3-inch by 3-inch PCB. And as I believe you were mentioning earlier about the solder mask, it comes in as a black solder mask right away. But whenever we do the push and pull from ECAD, because this has zero intelligence to the ECAD realm as it stands right now, right? So here we have our board. It's a new project. And what I'm going to need to do here is just open up the assembly that we were working with. Perfect. So here we have the enclosure. It's pretty standard, something that you can get off the shelf. A lot of manufacturers like Hammond or some other US-based manufacturers, it's pretty much something you can just grab. So it just has to reference the old SolidWorks part for right now. Perfect. Have our enclosure. And just like they were showing earlier, all we would do, or the mechanical designer, all they would do is bring in this board that already exists in their other file, right? So let's go ahead. We'll place that somewhere relatively close. It doesn't really matter for right now. And we can go ahead and create a mate. And what I want to do is I want to select the bottom of the board, and I want to select the face of the enclosure where we're going to have the board sit. As you mentioned as well, this is where the board thickness would be pretty important, right? Because what I'm going to show right now is that the board's actually just going to go through the bottom of the enclosure, and you'll probably get fired if you do that. So definitely not recommended. Make sure you have the proper board thickness. And we can probably just make this normal 2. Okay, let's see where we can change it. I have it a shortcut on mine, so might be able to do that. No, that's okay. Perfect. So we're working with something relatively close. Looks very similar to what David had. He wasn't far off by any means, so there's no problem there. Whenever we're editing a sketch, it would just like be editing primitives in Altium as well. You know how you just have it on your mechanical layer. If you want to go ahead and move some of these lines around, you can move that as you see fit. And Linda showed it very well in Creo as well, adding the fillets and everything to create that board shape. So instead of me just kind of guessing how this board shape is going to be kind of configured, your mechanical designer would know that, hey, I can just select this face and we can offset the entities. So what we're going to do here is we will offset entities. It's going to ask us to select which face we want to use. And I definitely had something already selected there, so I'm already making mistakes, which is great. They'll reverse the direction. And would anybody know what this parameter or what this offset entity, why that would be important? Why would that number that we're offsetting by, why would it be important? A little bit of wiggle room, right? So we have manufacturing tolerances with our PCB. If it's a plastic enclosure that's going into a harsh environment as well too, you're going to have kind of that flexing if it's hot or cold, right? So last thing you want to do is put it bang on of that face, and then next thing you know, well, my PCB board manufacturer was out a little bit and now it doesn't fit. So I kind of pulled it back just to say a little bit off the edge. I think that should be okay. So we should be able to click that. And we can delete the other primitives, because just like when we're trying to create a board shape in Altium, you can't really have two rectangles to create that board shape. And now we can kind of see what we're working with right here. Perfect. So once we rebuild it, we're looking pretty decent. I think there's enough clearance around the edges right here. And once again, we would push this over to the designer. Sure, we can do holes in here. I think the way we can do that is just edit this assembly. We can go ahead, create a sketch. We will sketch on the board. We'll create a circle. We can do that. Who here uses linear patterns? Or not a lot of mechanical designers in the room, right? Just a few of them, linear patterns? Yeah. So your mechanical designer, he's going to be way better than I'm going to be. And he's just going to, he or she is going to create a linear pattern. So what you can do is draw one circle, and then they can just space the X and the Y and just create 4 circles, assuming that there's 4 mounting holes. So not super concerned about the size of that. And from here, let's go back into assembly. See, just like David, I screwed something up. It's all good. Teamwork. I like to call it consistency, to be honest, but
You're just supporting each other. That's
Yeah.
a good thing.
perfect. Let's go ahead and edit this assembly. Yep. It's just that I had hit the wrong button before I had exited the sketch, because I wanted to smart dimension them at first as well. I might even be doing the wrong one. Edit part, let's try and do this instead. I wasn't necessarily prepared to come up and do it, but it's all good. So what happens is that whenever you have a top assembly, you're going to have the board, you're going to have the enclosure, you're going to have all that stuff, right? So your mechanical designer is going to know which assembly they essentially have to work with. So they would go and they would make an extruded boss. So the issue I was having right there is I was in my feature tree. I'll go through this first. So here we can go through blind, we can go up to next. They're going to know what they need to essentially do to make these holes. You're right, I did an extruded boss, thank you. Yeah. Right, they didn't exist, so I thought I'd make my own. Perfect. There we go. Perfect. So it took us about 27 minutes to make one hole, but it's really not a big deal. What was kind of funny, Yeah, so what was kind of funny with this too is that I had the 2-hour presentation on this as well on Friday, and I had essentially made a mistake to, I did the reverse where I picked the board instead of the board assembly. I was like, all right, cool, like I might just smash my computer, I haven't really decided yet. So, yeah, you were there for that? I think the good thing that most of you have been pretty patient with is that like we're all human, really, and I would rather not sit here and lie to anyone. I'd rather be honest about it and say, hey, listen, I made a mistake, I hit the wrong thing, and you get the idea. So when you have the actual board itself, the assembly, you can see that it updates automatically. So it's not like you have to have that enclosure to essentially be doing that back and forth. All you need to do is work in the top assembly. Anything that's done in the top assembly with that particular board is going to be okay. So I definitely think I clicked something I shouldn't have, but it's okay. And we'll push that, and we can say added mounting holes 27 minutes later. Right, added mounting hole. Added mounting hole. You know, I didn't sign up for this, guys. All right, come on. Yeah.
I go for an M10.
Yeah.
You make them big, you only need one.
Yeah. Perfect. So, as
I decided to move to Altium when it took me 8 hours to move a single via in board station.
really, kudos to you, sir, because you have way more patience than I do. Right? So as they showed where we already had a project that was already existing within A365, here what I did is I started the project in the mechanical realm, right? So I don't have to have Altium Designer open. I didn't start anything in Altium, but the project is readily available to me within Altium Designer already. So all I have to do is open that up. And as I'd kind of mentioned with the project templates, if you already have schematics and documents that every time you create a new project, this might not be the preferred method for you.
Wait.
Yes, sir.
You made it on the MCAD side.
Yep.
And it knew that this was going to become an Altium project and built it up. And if you had some scripting, you could follow through and finish the creation of it.
You got it. So because both Altium Concord Pro and A65, it's going to be installed where both the mechanical and the electrical designer have access to. So when they sign in to the server address where the product is actually installed, and they sign in with their AltiumLive credentials, and they both have access to that same product in the same area. So that's why here we can pull the board from server, or we can create a new board assembly. So let's go ahead and we'll add a new PCB project. And once again, it's not going to know any of the information from the mechanical side because I haven't done the push and pull yet.
Are the licenses for this floating? They can't be floating? MCAD,
You just would need a license to.
So the way the client access, yep. So I wouldn't consider it as a floating. It's not named floating, but the functionality of it is. So as soon as you have that client access license, it's tied into the software itself. And as long as you have connectivity to your server, it's going to work. There you go. So in this scenario, if we look specifically on Altium Concord Pro, you're buying one standalone or perpetual license, whatever you want to call it, the main server license, and then you have your user licenses. But it wouldn't necessarily be considered standalone. It would be on demand as long as you have access to your server and you're logged in. That's all you need. So I pull up the MCAD CoDesigner panel. It's going to say, hey, David, well, you took a really long time to add one mounting hole, not mounting holes, right? So we can view those changes. It's going to detect all the changes. You guys did a really, really good job of representing that. We can see we have the preview of our new board shape. And for the object, we're going to see that it's a cutout. So we can see here we're going to get the representation of the two holes as well. I will check all because I don't feel like giving my mechanical designer a hard time today and rejecting those changes. And we can see right here that, so we do have those as a cutout. So let's imagine that you have a mechanical product that's I worked at a company that did radios and cap lamps for underground mining, and we essentially used a Motorola radio that we took the PCB from, and we inserted it into our own plastic injection molding housing. I actually had some demos here today, but I had to ship them back up because I can't travel back to Canada with them. So I wish I would have had them here to kind of demo for you. But inside of the housing, there was almost like a little plastic lip. So we needed to absolutely have that cutout, and that cutout had to slide in. The only thing is that we didn't have a mechanical designer in-house. So I didn't have the capability of using the MCAD CoDesigner tool, so I kind of had to measure all these cutouts, where they were going to be, how much that board actually slid into the radio to know that I needed to create like an 1.5 inch slot, right? So that's a little bit of the benefits that we see from this as well.
My holes on my board
Yep.
are actually footprints because I include a bunch of mechanical layers
Yeah.
for the draftsman tool.
Okay.
Can you start on the MCAD side and place a footprint?
That will be coming shortly.
Okay, but that is.
Because we had spoke about the mechanical placement of components
Yeah.
Right.
from the mechanical tool, it currently does not exist, but it's on the way.
The part model. You'd have
Yeah.
you'd have a part model for it, and then that
But if
part
it's,
model would be associated to an ECAD.
But if the model, let's say, is a through-hole component model, you should still be able to place it from mechanical, right, Nikolai? Yeah.
As long as it's
So-
considered a part model. Yeah.
For mechanical side, if you just create that path by using whole feature.
Okay. The whole feature.
If you use the whole feature, you will get a path for multiple. By the way, why they cut out, there is not that's a cut out, all path because we have a special place for this, and that option says features cut out with the size more than X should be considered as cut out not a control. So if you create cutouts which are small enough, they will be considered as a pad anyway.
So,
Still show up, they would still show up as round holes in your drill drive, right?
and sorry, what's your name back there? I didn't catch it at the start. Yeah. Wayne? Wayne, so whenever you were asking about the board thickness and the solder mask, this is where we would see it right here. So from the ECAD side, we didn't make any changes to the board outline yet, right? We didn't change any of that. We took it from the MCAD. But what you see under the change column is that you'll see its thickness and color. That's the description we have there. So it's going to bring in our 60 mil from our layer stack, and Nikolai is very eager to answer something here.
I just wanted to clarify why you are seeing two cutouts on ECAD side and just one hole here. I think most of people have this question. So this is because
I screwed it up.
when we created a sketch, if you remember, which includes two circles, but when we created cutout for cutting through, we used only one. This is the reason. And when we transfer data to ECAD, for some reason, for some special cases, I would say, we consider actually all the content of the sketch as a whole entity. Well, I would say this is a special case. We know about it, and perhaps in future we will be smarter in this specific case, but now that's the way it is. So this is the reason why, because both circles were included in the same sketch.
And also, if I didn't make it,
Special case.
and if I knew what I was doing, that wouldn't have happened. No, should be able to edit part. Nope. Oh, okay. Can go into the main assembly, and in here. To
That's a good way to start. I like this. Yes.
I
Continue.
I actually didn't catch that first part, and I'm probably hoping that I don't want to hear it.
I have a subversive question, but I don't mean it in a
Okay, in a bad way.
bad way.
Okay.
What if I want, so right now if I just wanted to do a static export of a step file of a board with the, an exterior shell basically.
Sure.
Right now they're really big files.
Okay.
I tried doing it in one piece. I tried doing IDF with PRO and that person has to have all their own little models and it's very small, but they're managing a whole lot of stuff. I just want to hand a shape to a person and have them make an enclosure. I don't want to go back and forth. Is there a way to make these step files smaller? They can export it?
These aren't steps.
Step out the board, skip all the components.
One thing our guys ask for is for a meeting that care can export it. And these things will work better for them because they don't want to pay for it. Comes in and they get more components for them. So that's what
Is that what you were suggesting?
Yeah. Actually, so I just wanted first to suggest this fire code instead of that. This is the first thing. And the second one, I just wanted to tell you that we are going to introduce more options for making the data exchange faster. For example, we are going to introduce an option for simplifying modeling examples from ECAD to MCAD, or to ignore some models which are not necessary in most cases for mechanical engineering. So mechanical engineer will be able to choose how to get data, to get the full data or to get simplified data, or perhaps even in future to get whole board as a single file. But please keep in mind that there is an issue with constraints from your board to your enclosure. And if you are sending and transferring your PCB from ECAD to MCAD, you most probably are breaking your constraints. If you try to do that, you know this problem. And this is, by the way, one of the advantages of CoDesign, of this approach, because we are taking all those stuff into, well, not all from us, but we know what should we think about. So the goal is to keep those constraints healthy and not to break them, and to allow mechanical engineers to do design.
And I just have pretty much 2 minutes to go here because I just want to show you something else as well. First thing is they were not kidding about the pitch where this mouse is right now. It's like literally like this when I let go of it. So I thought you were just making up excuses, but really I was like, all right, he's pretty serious here. Additionally, one thing that we didn't show either is that the mechanical designer can move components on the board as well. So if there's something that maybe there's a cutout that has to go there and they have to move some of these components, they can do that as well. So yeah, say if it was in the way of a screw or something like that, that's a possibility as well. And they can always change the visibility of the actual PCB itself to bring in or look at any copper, because last thing you want is having copper near a mounting hole where the mounting hole is going to have the actual head of the screw, and you don't want that to be touching, whether it be ground, power, whatever the case may be. So if the mechanical designer wants to toggle the visibility of this board and see the layers that do exist, they can ensure that there's going to be no copper touching anything. So I'll just go ahead and push this board over to the ECAD side one more time just to show the movement of this one capacitor. So,
You need a SolidWorks connector license. That you must pay SolidWorks.
so I'll kind of expand on that without going much too down on a rabbit hole. SolidWorks and Altium have a partnership. They do have a similar product that's a dumbed-down version of what we have. If you want to take this route with ACP or A365, as per the end user license agreement, there's a partnership with SolidWorks that you would still have to purchase their connector license. It's a little bit of a undesirable scenario in some cases, but Creo does not have that problem as of right now. So let's go ahead and we can see the preview of the moved capacitor here. So just before some of you skip out, I just want to make sure that Linda and David have a chance to kind of wrap up what they wanted to show. You know, we all make mistakes. We're not perfect. What I said on Friday too, we said we all put on the same pair of pants at the end of the day, but sometimes mine are a little bit tighter than others, depending on what I ate the night before. So we appreciate your patience and working with us. And one thing that Nikolai said is Nikolai came over from Russia, correct? Yeah, so he came St. Petersburg's, Russia, yeah?
St. Petersburg, yeah.
So, yes, I heard the vodka's
Beautiful
good.
city.
So if there's anything that we can kind of take from you guys as well today is Nikolai is here for the feedback. We want that feedback. Please don't be shy. We want to make the product better, and that's why he's here. So I'll let you guys wrap this up, and I almost didn't make it through that.
By the way, if you want to know more about what the plan for the future,
Yeah. Yeah, actually, that's a good idea, Nikolai. So maybe have questions
Yeah.
and then give him a few minutes to talk about
So,
features.
Recap, right? We looked at working with the designs in a native environment, both on the electrical and on the mechanical side, right? Eliminating those exports, going back and forth with those exports, eliminating that time to actually render those exports over and over again, which is just going to increase the communication and efficiency. Because it's a lot easier when you're connecting. You're connecting to the same revision every time. There's no possibility for miscommunication because it is the same centralized location, right? And this just ends up reducing the cost of everything because you iterate much quicker. It makes it a lot easier to get out to market, and you're just ready to go. And lastly, I think we're looking for more people who would like to use this for simulation. The copper exports, just like to hear kind of what they would like to use it for. It does allow for that information to be used for that, and we just kind of want to hear more. Obviously, we're interacting with more on the electrical side, so it'd be nice to hear more about that type of thing. Stress testing, thermal simulation, et cetera. Obviously, there's the ability to be a lot more accurate when you have the exact model, right? If you create something in 3D that is accurate, then you're going to get accurate measurements. And you're going to be able to produce your board right the first time instead of going back and forth and having all these messes. So at this point, we're going to open it up to questions. I think we've been pretty open to questions. But I'm going to let Nikolai speak. The two things, the main things I've already mentioned on the roadmap straight ahead is placement from the mechanical side and actually resolving that so that once you have made that placement on the mechanical side, it will resolve to the components on your server so that you can place those edge connectors from the mechanical side and then instantly get going, right? Get those critical components out of the way and get your design going. And the other thing we were going to talk about the, okay, just making sure, like we're still, okay, rigid flex support, right? Currently, we obviously have rigid flex support in Altium Designer. How we get that information across in the mechanical side is, what's in the immediate future. And that is soon, right?
I was excited to hear what he had to say.
Yeah, he's going to say it now, but I'm just giving the recap. And, you know, so he's here. So I'll let him talk now, and then he's going to be here if you guys want to talk more about those things. I have some business cards up here if you want to set up some talks with me about any of the mechanical stuff, any of the Concord Pro things, any materials you think are missing. If you do start adoption of this, you're going to hear a lot from me because I made all the videos, so you're going to hear, you know. So, yeah, just please let me know. Be in contact if you need anything. Thank you.
So should I use this microphone? Okay. So as for Rigid-Flex board support, as David mentioned, we made the very first version of that support. Now it is shipped with SolidWorks PCB solution. And we are going to ship it a bit later than the official shipment of the 20th version of Altium Designer. I hope it will be done and will be shipped in January, according to our plans. It will allow to send Rigid-Flex boards from Altium to MCAD and to adjust that Rigid-Flex board to your mechanical environment or to the enclosure, to make changes to the rigid parts and flex parts, to make changes to band properties, to set of bands themselves, and so on and so on. The second step, so now I mentioned that it will be possible to send from ECAD to MCAD, but I think we all know that such kind of boards are actually initially designed by mechanical engineers according to that mechanical environment, mechanical enclosure, the device itself. And it will be the second step. So it is also planned. I hope it will be done closer to the summer, I guess, to the middle of next year. And yes, it will allow to create a Rigid-Flex board from scratch in MCAD, as it is possible with the regular boards now, as David showed. And that's it. So I hope that problem will be solved. If you want to know what else is planned, so I can tell one important thing. This is actually our strategic goal. So the goal is to allow mechanical engineers and electrical engineers to exclude, to get rid of any manual file exchange. Now that exchange is still necessary because mechanical engineers are defining not just a board outline, as you know, but they are defining placement keep-outs, trace keep-outs, height limits, and other stuff, some custom requirements for the boards. And the goal is to support all of that smoothly and seamlessly within our CoDesigner cycle, within our MCAD-ECAD collaboration cycle. So this is the main goal. And additionally, as I said, and David said, we are going to ship MCAD side component placement. And the second step with that specific functionality, with component placement, will be working with the storage or working with PDM or PLM system on MCAD side and placing the native components from that system, because quite often companies manage or support their component libraries, including the models of components in PDM or PLM systems, and want us to support that, to support those storage. So It is going to be done till the beginning of next year, and the first pair of MCAD and PLM supported will be Creo plus Windchill. Next will be SolidWorks plus SolidWorks PDM, sorry, which again will allow to manage components smoothly and will allow to avoid duplication of components of models on MCAD side in MCAD storage or in PDM system. And this is, by the way, also quite an important issue. If somebody faced that, then I think you know what I mean. So, and other improvements are planned as well, but I would say they are less significant than what I mentioned. So if you have more questions about what is going to be done soon or in midterm future or in long-term future, please welcome. Don't hesitate to contact me or to contact David or Linda, and I think they will just redirect questions to me. Thank you. Thank you and welcome. And